Thank you for joining me for another episode of Empower Apps. I'm your host, Leo Dion. I'm joined once again by Matt Masicotte. Matt, thank you so much for coming on.
Thank you very much for having me again.
This is number 3 appearance. People probably know you, but I'll let you go ahead and introduce yourself.
Sure. Well, my name is Matt, and I'm a longtime Apple developer, and lately I've been putting a lot of effort, apparently, into concurrency. It's like my main thing.
So you were on last time to talk about concurrency. You're back on to talk about concurrency and the future of Swift. Yeah, let's just jump right into it. Where do you think concurrency is at when it comes to Swift 6 and how things went with Swift 6 and actors and await and all that stuff?
Well, I think that most people are going to have trouble adopting Swift 6. And I think a lot of people kind of naturally are trying to do it because it's this new thing and it's been released. And so because it's released, it feels like it should be the thing that we use. But I think that for the vast majority of projects, Swift 5 mode is the right thing to choose, and then to just incrementally work your way towards going in this direction.
What if you're starting a brand new product?
I think that if you're starting something brand new, especially like if you're starting with nothing carried over, then sure, go for Swift 6. It's usually a lot easier to do it with a new project than it is to migrate existing stuff. That's really the big problem, I think.
Okay. Do you think, where do you see the issues as far as, for the most part, for people's mental model of how they think it works versus how it actually works?
The big thing that happened, and this happened to me, and I think it happened to a lot of people, and I still see it happening now, is they're using async await kind of like as a syntactic convenience over completion handler. And it feels that way in a lot of ways. And so you might like have an existing project, all the warnings are off by default, and you just start saying like, oh, instead of having completion handlers ever, I'm just going to use async await, and it's all going to be the same. And that is not true in the general case. And there are very trivial examples where that will change not just how the code looks, but it will change the semantics of how it works as well. And so when people get themselves, like when you were asking about a new project, you can kind of catch yourself from the beginning because Swift 6 mode will present errors as soon as you make a mistake. But Swift 5 mode, especially with no warnings, for the most part won't show you anything. So it's very easy to make these changes that are mostly correct and mostly fine, and you start having this big project that is adopting more and more of this stuff. And when you finally do flip on the warnings or try to use Swift 6 mode, you'll inevitably discover some stuff that isn't right. And that's when it can be hard to fix.
So I have a few thoughts about that. It's interesting you said syntactic sugar, because that's exactly what I had thought before async await had come. I had thought that that's essentially what it was going to be, was kind of like promises underneath, but like basically it's still not changing a lot. So my first question is the problems that Swift 6 addresses when it comes to concurrency, were those issues that had already existed, but we didn't notice under GCD?
Well, like one example is you have some API, right? And it's got some callback, and it says, and you need to know, well, does that callback happen on the main thread, or do I need to dispatch over to the main thread to handle that callback? And so that's a really common pattern where many people will just not look at documentation, not read how things work. They'll just always put a dispatch to main. And that's safe because then you never have to worry about whether you're being called on a background thread or not. It is also inefficient, but it kind of shows you, it highlights the general problem of if you miss that in even one single spot where you happen to not realize some API is calling you back on the main thread and you don't put that callback in, then inevitably you'll run into problems. And this is like a really common problem. I'm sure you've had this problem happen to you as well.
Yeah.
A super common problem. So that's one of the things that Swift concurrency fixes, is because that this information of like, should this be main thread or not, is built into the signature of the function. You cannot get it wrong. You don't even need to think about it. You just like run your code and it'll automatically do the right thing. So from that perspective, I love that because that's a really common problem.
We talked about previously in the last episode with Donnie about the whole having to mark things as main thread and the plan to like change that going forward for like if you call something from main thread, you call it async function from the main thread. They're looking at like proposals about that. Do you know what I'm talking about?
Yeah.
You wanna just kind of explain what that is and what it's supposed to address?
Yeah, well, there's a lot going on there, a lot. But like one of the things is you had said, and I thought too, that async await was just syntactic sugar for callback. And that is true, provided that the isolation of the types involved don't
Right.
change.
Right. Exactly.
But what's interesting is there was this proposal that was introduced, I don't know, like Swift 5.7 or 5.8. I can't remember exactly what it was called, but it changed the semantics, and it very clearly specified that if you have a non-isolated asynchronous function, it's always going to run on the background. But what that did was it fixed a couple of performance issues, but it made it so it was no longer true that these things are just syntactic sugar for completion handlers for most uses. And so that one little change ended up having widespread implications to make it really hard for people to do the right thing unless they deeply understood this implication. But that is going to get changed. And just that one change,
That is actually going to get changed. It's not a
well,
proposal.
it's being worked on.
Okay,
But
gotcha.
it hasn't actually been formally pitched or formally proposed yet, but I think it's going to be. But I bring that up because talking about how all this works, there's a lot of lack of intuition. So how you might expect the code to work, and maybe how you have code written that works today, it will like start working right when this is changed. It has a bunch of other positive impacts as well. I mean, I think this was a very I'm not sure why this change was made originally, but
Okay.
I am looking forward to it being undone.
Okay. Okay. Um so what are some other misnomers that you've seen people pick up when it comes to concurrency lately?
Um, well, so one is like not understanding the implications of asynchronous functions. This is what we were talking about.
Yeah. And I
Um,
think that the whole like isolation stuff, like when it was first introduced, actors were just like, yeah, I'm not dealing with that. I don't want to have to deal with it. And then like the more and more I deep dived into async away, I was like, okay, yeah, I need to know how this stuff works.
mhm.
Because like you said, it isn't syntactic sugar. There's a lot going on there, especially concerning isolation. And like, I mean, essentially what we're getting at is like not dealing with race conditions, right? And stuff like that, where you don't want two people doing the same thing and messing stuff up, or two actors, I should
Right.
say.
Yeah.
And I think that safety, that thread safety, was something that I think we didn't realize needed to be done, that wasn't being taken care of in Swift, and it's like augmenting part of what makes Swift so great is that safety. Um, and so for me, that was a big revelation. A lot of the work that you've done has been a big revelation as far as like what Swift 6, what async await, and what actors are trying to do.
Yeah, I mean, that's the only reason it exists is to do safety. It's also nice. I mean, I like that you no longer need to check the documentation to figure out, is this thing being called on the main thread? Do I have to use this thing only on the main thread? It's
Right,
cool that you don't have to
right.
look at documentation anymore. But the big focus was around safety. You're absolutely right.
So actors, I mean, is it come down to like actors being the big challenge when it comes to async await and isolation more so than the like not concurrency, but you know what I mean? Like, is that where it really comes down to?
Well, I think the challenges people run into is taking their existing code that doesn't use concurrency primitives, or, and this is worse, uses concurrency incorrectly, and then when they want to move that to a warning-free or error-free state. But if you're starting with something that like you have absolutely no async await in your code base, and you just want to start like seeing where the warnings show up, it's not usually that bad to start expressing the reality of your code to the compiler. For example, adding things like this is unchecked sendable, this is non-isolated unsafe. Like there are all these called opt-outs, these tools that you can use to tell the compiler, I am doing the right thing. You don't need to check this stuff. Now the advantage of that is that gets you really far. And the disadvantage of it is it turns off all the checking. So like, I'm not sure if you were saying what I want to do is use Swift 6 with no errors and have all these opt-outs turned on. I don't know what the advantage of it is really,
Right, right,
unless you want to start now in the future moving towards not doing that anymore.
right, right. So let's talk about that. Where is using unchecked send? Well, let's try it with unchecked sendable, and then we'll move to pre-concurrency. Where do you think it's useful to use unchecked sendable? Where it's
Well, like
yeah, that's okay.
Imagine you had some class that you made that is like a dictionary plus a queue, and it's just this thread-safe version of a dictionary, or a cache, or something like this. Just some thread-safe type that you're using for whatever reason, but it protects all its state internally. That thing is unchecked sendable. You make it unchecked sendable, and you're done.
Okay. How about, is there ever an instance where you just don't care?
You don't care whether it's safe or not?
Yeah. Yes.
Probably that's true. And I think really, I think there are many people that have come to Swift concurrency saying, well, I just think my code is fine. I don't understand why do I have to deal with this stuff at all? And I
Right.
think today, the answer to that would be then turn off the warnings, use Swift 5 mode, and then you're mostly okay. There are a few bugs that are currently exist in the Swift 6 compiler that make it so that even if you do turn off everything, you still see some warnings in certain circumstances.
Okay. Okay.
But I think it's relatively rare. But that's not usually what people are seeing. What people usually are seeing when they get frustrated is they're using concurrency, they're using it incorrectly, but they're getting frustrated because they just want the warnings to go away. And the solution to that, there is no solution to that, because you can't use the concurrency system but then have it not tell you that you're using it wrong.
Right. Right. That's the whole point.
Yeah.
I mean, so are the gains by using it correctly like performance, or what do you get from switching over to Swift 6 doing it right as opposed to Swift 5?
Well, I guess, so I'm interpreting your question to mean you're migrating from using something like GCD to using the concurrency from Swift.
Mm-hmm.
And in that case, there are some potential performance gains. So this huge emphasis was put when Swift concurrency was first introduced on like reducing context switches. And the idea there was, instead of having your code bouncing around between different threads, you have this small set of thread pool threads, and then this work can be divvied up without actually necessarily needing to hop around or spawn different threads. So GCD and concurrency, one of the things concurrency was trying to do was address this problem. And you can see there's a WWDC talk that goes into like depth about the idea behind this.
Okay.
Now, I'm kind of trying to focus on the idea because in practice, I've done zero really investigation into this. So I don't know for a fact that you will see performance gains or losses by making these changes.
Mm-hmm.
But that's one of the ideas.
You're going to say another one?
Yeah.
Or?
Well,
Okay.
the main focus of it was not so much performance as it was being able to use concurrency without having to even really think about whether or not you're introducing data races. That was really the big focus.
Right, right. So, I mean, to me, like the emphasis on concurrency was always the fact that, I mean, we could get into it, but when I did my talk at 360 IDEV a few years ago about the future of like async, this would have been almost 10 years ago, geez. But the idea is like, we want to do async away for the syntactic sugar, but also the fact that like, I don't want to say we've hit like the edge of Moore's law. I don't know where you're at on that, but the fact is we've moved away from like, getting faster and faster processors to just having more and more cores. And the fact that you can divvy up jobs to multiple cores makes it more advantageous to want to do things on more cores as opposed to like just like, because your processors aren't going to get faster per se as much as you get more cores and can do more things at the same time. And that's where the advantage is. Am I mistaken in what I said, or like is that the benefit of concurrency or doing things concurrently, or is it like with context switching, is it just creating more work than it's worth?
Well, so one thing I'll say is single-threaded performance has been getting significantly better year over year and continues to. I don't know that that will continue forever, but it certainly has been the case.
Okay.
So it is true that, like, generally speaking, there's been more cores per processor over time. That's true. But also, even if you don't use any concurrency at all and just have a single threaded program, they're also getting faster.
Okay. Okay.
Now, I think that one of the things that I've seen people do with concurrency is like this. It's almost like this fear of the main thread, that they want to get everything off of the
Ooh, I
main
like
thread.
that. The fear of the main thread.
Well, it makes sense because it makes your app unresponsive. So the
Right.
idea is you want to get all that work off the main thread so that you can have it be available to service user input or other kinds of events.
Right.
But the thing is that there's overhead. So moving something off of the main thread, even to one of these, to anywhere, it has a little bit of a cost. It's usually very small.
And this is you're talking about the context switching.
Yeah, exactly.
Okay.
It takes some amount of work for the computer to be able to no longer run this stuff on the main thread and do it somewhere else.
Okay.
And so as long as the work you're doing outweighs the cost, then it's a win. But if it turns out that the work that you're switching off of the main thread is minuscule, is teeny, like a very small amount of work, and you're doing it off of the main thread, so you're transferring the work off, and now you have to deal with, and now my user interface can still accept input, right? So I have to maybe like turn off a button or put a spinner, and then you finish, and now you have to move that work back onto the main thread. So there's overhead and extra complexity, and as long as it's worth it, it's good. But I've encountered certainly a number of applications where they're shifting these minuscule amounts of work off of the main thread to do basically nothing, and then move it back onto the main thread, which causes significantly more complexity for it's actually a negative performance benefit. It's faster to just stay on the main thread and do it all there.
That's really interesting. I don't think a lot of people know that, Matt. Like, I think a lot of people think, like you said, oh, we should just have it all like on the background and then only have the stuff that involves UI updates on the main thread. So I agree. I don't like it makes sense. It makes sense what you said, and I think a lot of people don't know that.
Well, I think their intuition is so close. I think people really have the right idea, which is your fear should be of long-running synchronous work. If you have anything, like take the super classic example is you're going to download some JSON from the internet, you're going to decode it and turn it into some model or something.
Mm-hmm.
That JSON is probably normally small. Maybe it's even tiny. And it's true, if you do the decoding and parsing on the main thread, it might actually be faster, but only for that particular input. In the general case, you could get these massive blobs of JSON, take a long time to decode. So those kinds of things, they make sense to offload to a background task and then to pop back on.
Okay. Is there anything else we're looking at as far as the future of Swift and concurrency going forward with 6.1 or 6.2? Besides the other thing.
Well, 6.1, I'm very excited about 6.1 because there's a whole bunch of bugs and I guess I'll call them limitations in the existing 6.3 compiler that 6.03
mm-hmm.
that I'm looking forward to seeing them fix.
There
was a lot of new features added with Swift 6, and some of them aren't quite as robust as I think they should be, and I think that 6.1 is going to do a lot to fix that.
Are they concurrency related?
Yeah. I'm only talking about concurrency related.
Yeah. What are they? Do you want to talk about them?
Well, for example, there's this new keyword called sending, and sending is like, you can think about it as this lower bar than sendable. Sendable, the whole type needs to be thread safe, and sending is more like just this one spot in this one case. I'm going to make it be that can the compiler prove this is safe? So sending is really wonderful, and it really is this great tool, except I have found many limitations where the compiler is too aggressive, too conservative in avoiding using it, and so it doesn't let me do the thing, even though I'm pretty sure that it should. And there's a lot of bugs that have been filed about this, and many of them are fixed, but just not yet released.
Okay. Yeah, we just talked about that in the last episode with Donnie. So I want to talk about that a little bit. Is this whole world of like perimeter argument prefix keywords that I'm like totally not familiar with. So like So, like with the non-copyable stuff that they talked about at WWDC, right? They introduced a few, and then we have sending, and then we have isolation. Like, kind of, especially the isolation one. I still don't understand how that is supposed to be used in a method
You know,
signature.
I think that's good. You shouldn't need to understand it. And
Okay,
as soon as the non-isolated async change happens, which I hope it does, you won't even need to understand it.
okay.
Unfortunately, we're not in that place today. Today, it's a critical tool for certain kinds of problems where you really can't get around it.
You want to explain what those problems are?
Well, I mean, what it really comes down to is if you want to add a asynchronous function to a non-sendable type, you can't really pull that off without understanding how. I think you're talking about isolated parameters.
Yes, exactly,
Yeah,
100%.
yeah, you can't really pull that off without isolated parameters. And
Okay,
so, like a common thing I have seen people do is they'll take some type that they don't control. It's from some library somewhere, and they want to wrap up something that the library provides with an asynchronous function. If that type that you're wrapping up though is not sendable, you can't really do that.
okay. I know exactly what you're talking about
Yeah.
because when I bug you on Slack, one of the things lately that I've been bugging you about is the virtual machine stuff. And like there was something specifically related to that. I think it was like either starting, well, it's weird because virtual machine or virtualization, I should say, framework has a bunch of async await methods, but then they're classes and they're not really sendable, and it's like kind of a mess.
Okay. Well, actually, wait. So is that but that framework is an Objective C framework?
Yeah, yes, we've
Yeah.
talked about this
Okay.
offline.
So that's important because the comp- well, I don't know the history of this or why this happened, but the compiler does this automatic translation in both directions, from
Right,
async to completion handler and then back again.
because it's syntactic sugar, Matt, so that makes total sense. We
Well,
just
I think okay. So this is speculation. My speculation is what happened is that was added before the change to non-isolated asynchronous methods was made, and that was added to the compiler, and then they changed this, which caused that translation to not work properly, and they left the translation in. I'm not sure why that was done.
it's
Um,
documented too. So it's
well,
like
listen,
it's not an accident. It's like they actually document it in the, like if you go to the Apple
I
documentation,
know,
they
yeah, I've seen it. It's not a safe thing to use. You can't really use the compiler bridging from async to completion.
I swear. Oh my gosh. This is what drives people crazy.
Yeah, I mean that's a tough one. I don't know why that wasn't
And
once it was.
I get the translation, right? Because we've gone through this crap before with like you could do syntactic sugar and Objective C for generics, and you could do stuff for like throwing.
Mhm.
So yeah, that makes total sense. And then what you're telling me is like they are treating it like syntactic sugar in this translation stuff, but in fact they're not taking into account the ramifications of what that really means.
Well, okay, so the most charitable um, point of view on this is it's not that it's wrong. It will work, but only in very narrow circumstances. So it could be that the reason that it was left in was because it still can potentially work sometimes. It just depends on your usage. And if you use it wrong, it will be caught with warnings and errors.
Okay.
So it could be, and again, I'm not sure this is the case, that it was left enabled because that you can use it correctly provided you follow the warnings and uh, use the diagnostics as
I
guides.
mean, I've never gotten a single warning about running any of those methods. So, like, I mean,
If they're non-sendable type, then you should receive a warning if you call it from an isolated context. But it's
okay.
possible you aren't. So if you aren't doing that, then that's an example of where it could work.
Okay. Fair enough.
So like I'm not saying I'm not saying that the Objective C async translation stuff never works. I'm saying that it is, you have to really understand what's going on if the types are not sendable.
Did you ever look in Objective C if they added any documentation for like how it should be translated? Like, can you put any macros or like things in
There's
it?
tons. So there's tons of Clang annotations you can use to put things to put Swift only annotations in your Objective C code.
Right.
Yeah, those all exist.
Okay, so is there something to deal with this situation? Like, let's say you have some old Objective C code and it's out there, and you want to make sure that no, don't create a async await version of this completion handler. Is there a
Yes,
way to?
you can suppress the
Okay,
async version. You can also do things like you can add at sendable annotations to closures, which is a very important thing to do. You can do that from Objective C. You can mark types as sendable, as main actor. You can do pretty much everything in terms of annotations with from Objective C code that you can do from Swift.
okay, okay. Um, so we talked about this. Like in my case, would it be useful to use pre-concurrency on the virtualization framework since
I
it's
would have to look more closely at it to say with confidence,
okay?
but it's possible. So
So yeah, go ahead. What would be a good case for where you want to use pre-concurrency?
Well, okay, so let's just pretend that we won't talk about virtualization because I'm not sure.
Yeah,
But
yeah, yeah.
you have some library and let's say it's in Objective C. It hasn't had any updates whatsoever. So today in your Swift 5 no warnings world, you have to use it correctly, right? If things have to be called on the main thread, you have to do it on the main thread. If you have to supply your own queue, you have to use it correctly. So if you import pre-concurrency, what you're telling the compiler is, I am using this right. Stop complaining about the types that you can't tell. So when you import that framework with pre-concurrency, you're basically telling the compiler, what I'm doing is fine. But that's not necessarily the case. But
Mhm.
as long as your code is right today, then import pre-concurrency makes sense.
Okay.
Unfortunately, one of the disadvantages of it is that it applies to the entire file.
Okay.
So what's happened to me sometimes is I'll have a big complicated class and it's got one little use of a framework in one spot. And that type there is not sendable, but I know I'm using it safely.
Uh-huh.
Now, if I import the thing pre-concurrency, I could later accidentally make a mistake and the compiler won't warn me about it.
Right, right. Because it does it to the whole framework.
Yeah, it does the whole framework in that file. Yeah, so
Yeah.
what you can do is separate out just that one usage. You can even do this with extensions. You can like split a class into multiple files.
Right, right.
So it's kind of gross to do that, but that is maybe a thing you want to consider doing.
So basically put that little one use in a separate file in an extension.
Yeah.
Okay.
If you're really worried about it, then that makes sense. I mean, I've also seen the opposite case where there are people that are using code wrong today. They turn on the warnings, they discover the compiler is unhappy all over the place, they throw a pre-concurrency on there, and all the warnings go away. But the code's still wrong.
You had a really great blog post about why you don't need to make everything sendable. Maybe you want to like quickly summarize that and where people fail in that aspect.
Well, a thing that happens is that you turn on warnings, and immediately you're going to get a lot of warnings that reference sendable. This type isn't sendable. You can't do this because it's not sendable. And so your reaction, you're very strongly pushed towards this direction of just make the stuff sendable. Everything works so nicely when things are sendable.
Yeah.
So it's very normal, I think, to have that kind of feeling, especially if you don't really, you're just getting started and you're getting started with an existing code base. But usually, I think what you want to do is like think harder about, do I want this thing to be sendable? Why does it have to be sendable? Maybe I shouldn't be bouncing this stuff around between lots of different threads. Like maybe it should all stay on one. And so my go-to is always, can we like not need this thing to be sendable in the first place? That's a better place to be.
So for me, like, this is where you're going to tell me I'm wrong, because that's what this whole episode's going to be about. So for me, like, sendable is basically like, if it's a struct where it's just data, like, it's okay to just make all those sendable because they're simple enough and who cares. Whereas classes, I would never make I would like try really hard never to make a class sendable.
No, I think you're right. I think that's totally the right. Totally the right way to think about it.
Okay.
Uh,
Classes should never be sendable because they're reference types, and that's a mess waiting.
I mean, I don't want to say never.
Not never, but like, it's a lot of work to make a class sendable. Like,
okay, but that's the key. What you just said there is the key, is that if you have to do work to make something sendable, that's a strong signal. You probably don't want it to be sendable in the first place.
And if it has to be used, what I wrote in my blog post was basically, if it's a struct and it's fairly like just data types, then yeah, go ahead. You can make that sendable. You should make it sendable.
Hmm.
Kind of like you'd make it codable or you make it equitable or something simple like that.
Yeah.
Um, Whereas if it's a class and you really need it to be sendable, at that point you may as well just make it an actor, because then that way, like you're taking care of the fact that like you'll never have an instance where you can't write and read essentially at the same time, and actors kind of handle that.
Okay, so first, in terms of like structs and simple data types that are just packaging up a bunch of data and moving them around, like I make so many, it's almost like a default. When I make types like that, I put sendable and hashable. Like I add
Yep,
those two things to
exactly.
almost everything.
Same
Yeah.
here. Yep.
Yeah. So, and I think a pretty good rule of thumb is if it's easy to make something sendable, you should go for it. Now, classes are not easy to make sendable, but it could
Right.
be, like we talked about before, that this is a thread safe type. It just happens to be a class. Then uncheck
Check
sendable,
sendable.
makes
Right.
a lot of sense.
Right.
Now, you brought up another thing, which is I really want this type to be sendable, but that's hard, and you're right. So I'm going to make it an actor. Now, actors are super cool because the good thing is they are sendable, and they also protect all their internal states. And you can have all kinds of garbage in there that is not safe at all, but the actor will keep it safe.
Okay.
That's good.
But Leo, go ahead.
They come with trade-offs, and the trade-offs are significant, right? So the first one is now to the outside world, everything has to be asynchronous. Their interface is now always asynchronous.
Right. That's 100%. Yes.
Yeah, and that can be like a very profound and terrible change to a code base.
To a code base, but how about to the app itself, like in performance? Because we talked about context switching earlier. Like
I mean, yeah, okay, that's true. I wouldn't really give that a lot of thought unless you're very
okay.
I really don't want to emphasize context switching as being a problem. I don't think it is for a large majority of apps.
Oh, okay.
What I meant more was it's not so much the performance that's the problem. The problem is you're paying this complexity cost for performance you don't need. That's really the more important thing.
Okay.
Is bouncing around to the background to actors to basically manage like very small amounts of state. It's so much, first of all, simpler, but also could be more performant to just leave that stuff on the main thread. I mean, you can kind of tell.
Right. Okay, so you're basically saying if you need to make a class sendable, you should really consider, instead of making an actor, make it on main actor.
I think that's often exactly what people need to do.
Okay.
Now, another thing, a second part to that is, this is getting a little more complicated. Most apps have a tremendous
It's perfect for a podcast for people listening in the car. This will be great.
Okay,
having the kids in the car that can listen to this. Yeah, no, go ahead.
Well, I mean, main actor is your first try, right? As soon as you have a thing, especially if you find, well, what I really want to do, this happens all the time, is I have this one spot where I want to read or write this data synchronously, but I need to do that from the main thread.
Yeah.
That's main actor stuff. There's nothing you can do about it. The compiler is telling you you want this to be on the background, but that has a big cost, and your design doesn't support that cost. So if you run into that kind of situation, you really have to think hard. Am I willing to totally redesign how my app works to make this an actor? Or can I just make this main actor and it's going to be fine? And as long as there's no long-running synchronous work, you are going to be fine to put that on the main actor.
I'm trying to rephrase this. So what's the benefit of using main actor instead of putting it as a class, as an actor, if you don't care that everything is going to be async await?
If you don't care that things are going to be asynchronous, so there's one other problem with actors compared to, for example, main actoring everything. And that problem is not only is its interface asynchronous, but all the inputs and outputs have to be sendable.
Right, okay.
Because everything has to transfer from wherever it is, presumably main actor, to this actor and then back again.
Yep.
So what ends up happening is you have this problem. You started with, oh, I just need this class to be sendable. I'm going to make it an actor. But now you fixed that problem. And in exchange, now all the inputs and outputs to this type now have to be sendable. And so usually what happens is you get down in this, it's this like never ending, you're just chasing over and over again. That type has to be sendable. This has to be an actor. Now this has to be an actor. This has to be an actor. And what you're doing is you're adding more and more concurrency, which means you're more and more sendable types. And that might be what you want to do. But I usually just don't do that.
Because it's a lot of code maintenance work.
It's a lot of work. It's a lot of change. Especially, I mean, if you're doing something new, I think it's different. But
well, that's what I'm saying, is like doing something new, which of course is only 20% of the work out there. But you know what I mean?
Yeah. I mean, actor is a rare thing. I have to really be able to justify to myself. I actually tell a lot of people when they're first getting started, you want to make something an actor, I want you to write like a little code comment on the top of the type and say, this is an actor because. And if the because is I need it to be sendable, that is not a good enough reason.
Okay. Okay. Because if it's synchronous, you'll never run into the situation of.
No, yeah, I mean,
Yeah.
unfortunately, today, if you wanted to make a class, which is very reasonable, to be used from a bunch of different places, and you wanted to have asynchronous methods, or even like participate in concurrency in any way, today, to do that is possible and requires a very deep understanding of how isolation works.
Okay.
But that's really unfortunate. That's just the reality, though.
I mean, would you say, is that something that we could. Is this something they can fix in the language, or is it just that's the problem of dealing with thread safety?
Nope, they're going to fix it in the language because this problem all really comes down to how non-isolated, and this is a plain class, no isolation, and asynchronous methods work. And they're going to change this, or at least it's being talked about being changed.
And how are they going to fix that?
Well, what they're going to do is for a non-isolated type, non-isolated asynchronous method today, it automatically goes to the background always.
Okay. So that's what we had talked about earlier, is
Yes,
that
it's
that
exactly
way
the
it
same
will
problem.
go, if you have a class and you're running it in main actor, it'll stay in main actor. And then
Yes, exactly. So
if you run it in something outside of main actor, it'll stay outside of main actor.
yeah, so the reason why that's so important is that it means that you can just use these things normally, like you would normally any other thing. It makes it much more like syntactic sugar for a completion handler,
Right.
and it's just such an easier model for people to understand and use for regular code.
Um so Matt, I really like, I'm not being sincere here. I'm just going to be an advocate, devil's advocate for this. I really hate that they're changing that. How can I make sure that my method goes into I guess you could just mark the method as non-isolated, right? I guess, or how would you be able
So
to you go
what
back to the way it is now? I
yeah,
guess.
yeah, yeah, very valid question. So that's part of this proposal that is, remember, it's not finalized yet.
Right, right.
But part of the proposal today, what it looks like is if you want to make a method that runs on a background thread specifically, you have to annotate it with something like @concurrent. This is
Oh,
what's
okay.
currently proposed.
Or some keyword that they'll come up with.
Something somehow you have to indicate this is a method that's going to run not on the existing isolation.
And is this for 6.1, 6.2? Will this
It
be
is
June? Will this be like
it is not even in proposal form yet.
okay?
So I don't know.
So that's what they're working on. Okay, fair
But it
enough.
would be cool. I mean, I would love to see this for June, but I don't think it'll be any sooner than that.
Can I so one thing, I don't know if you tackled this in a blog post or somebody did. Is main actor always the main thread?
Mm, yes, I, I
Okay.
have I have sometimes said to people before. So the confusion, there's a little tiny bit of subtlety because if you make a type main actor, a lot of people remember they're scared of the main thread. So they see main actor and they think, no, I don't want this to be on the main actor. But the reason they're saying that is because there's one spot in one method that can run some long running synchronous code. And so, but main actor always runs on the main thread. But
Okay.
what you can do is take a main actor type and then just carve out this one little method that runs in the background.
Okay.
So if that makes sense, what I'm saying is,
Put that in a
yes,
different class or put it in a different.
it can stay in the same class. You can have everything be a main actor type and one method of that type not be main actor
How
isolated.
do you mark that?
Today, non-isolated async.
Oh, okay. That
Yeah.
makes sense. Um so I feel like we covered a lot. So is there anything else we need to cover with actors and isolation that we haven't already?
I mean, it's a big topic. We could talk about it all day, but it seems pretty good what we've gotten to.
Okay, okay. Um, so besides concurrency, what else do you have to look forward to in Swift in 2025?
Oh, that's a very good question. I've been so focused on that, to be
Yeah, I
honest, that
know.
I'm not even sure. um, what else to look forward to? Well,
So we talked about this offline, but parameter packs, fixing those.
yeah, I have used them a little bit, and I think they're very far along. They're very usable, and they added a bunch of things in Swift 6 to make parameter packs even more usable. Because I think before there were some pretty rough edges.
Hmm.
But there are some spots, definitely, if you start getting deep into parameter packs, there are some spots where it doesn't quite work the way that you'd hope.
Yeah,
So
we talked about this with, I was trying to set up a parameter pack, and I posted it to the GitHub issue for Swift, but yeah, I forgot what it was exactly, but yeah, that we talked about this on Mastodon probably too, but yeah, that was the one thing that like kind of stopped me from using parameter packs further because it didn't do that one thing that I wanted.
I was able to, for what I was trying, I've used them one time for exactly one project, and I was able to pull off what I wanted, but I remember struggling a little bit here and there. Parameter pack, kind of the same thing as Sendable, sending, and it kind of reminds me of like the earlier generic days of Swift 2, where you look at the language and you write something and you think, this should work. It totally makes sense given my understanding of how this all works, but
Right,
the compiler just isn't quite there yet.
right, exactly. Yeah. Anything else you're looking forward to in 2025 when it comes to Swift?
Oh, I mean, I've been ignoring so much of the proposals and everything else going on because I'm so focused on concurrency. But personally, what I would like to see, I mean, there were some major improvements in Xcode with Xcode 16. Two things that I loved
Okay.
was the support for editor config, which is this like way of configuring how your editor behaves.
Okay.
It's
What
supported
is
by
so can you do like a dot file and then Xcode will read
yeah,
it? Is
that's
that what it is?
exactly it.
Oh,
That's
awesome.
exactly it. And it's
Okay.
cool because that format is supported by basically every other editor in the world
Right.
except
Right.
Xcode, but now it is, which is really wonderful. But the other thing that Xcode has done, which I think is really cool, is they've made it so that instead of having its own internal project structure with groups, you can just reference folders directly, kind of like how SPM works, and they'll just
Yeah.
automatically compile whatever in
Yes.
that folder.
Yes.
And that is life-changing. I mean, it's such an amazing feature. I can't believe it took so long to arrive, but it's really, really great. And I just want to see more related to SPM improvements.
I like the file creation is a big update in Xcode that I use a ton now. So you can create a new empty file. You can create
Mm-hmm.
a new file from the clipboard.
Yeah.
You can select a piece of code and say extract this into a new type or new file.
Mm-hmm.
Like that stuff has been amazing, and I've loved that. That to me has been a big advancement in my workflow.
Yeah, I've liked that a lot as well. But what I really want to see them do is address some of the usability problems, not with your experience using the editor, but with what the editor is capable or what the IDE is capable of doing. Like SPM has some pretty big limitations and just a lot of problems. For example, you can't build your project if you don't have an internet connection unless you pre-cached your SPM
Right.
packages. Like
Right.
that's terrible. These kinds of things need to be improved. And I think that SPM is so wonderful because it went so far towards being like more easier to use open source software, contribute to open source software, but it just isn't quite there yet where it
How
feels
do
like
you fix that problem if you're like resolving a package and you don't have an internet connection?
well, I mean it has one locally now.
Right. So you would just say you're talking about like the machine SPM cache. Like
Yes,
why not just
exactly.
use that? But if you
Yeah.
don't have it in that cache,
Yes,
so
of course. There are
but
situations
but
where
the problem you're saying is like if you have it cached globally, why is it still trying to go out on the internet? And
yeah, I mean, I think maybe a warning is fine telling me I want fresher data and I don't have it. That's okay. But to fail to build when you just because you don't have internet connection makes absolutely no sense.
yeah, that is really weird. Hmm. Huh, that is a weird thing. Or at
I
least
don't know
have a
that will.
flag.
I don't know
Like
that it'll happen in all cases, but that's been a tough one that I've experienced. And I've
okay.
also found a lot of other SPM related problems where um, it can just be hard to use for more complex projects. And I would love to see it just bug fixes basically. I just like to see it work better.
What are some of the problems you've run into with bigger projects?
Oh, I have this like long-standing issue with an SPM package that itself builds a C target.
Oh yeah.
And if you do that, that works fine unless it's part of a static library in an X. There's a combination of there's like a combination of setup that will result in it just not working properly without a
Yeah.
crazy workaround required.
I've recently dealt with XC frameworks and like
Mm,
I'll say thank God for like AI, because like I could not figure out how even AI got it wrong, but like how to get it to build multiple frameworks and then package them and like get that all in a GitHub workflow and all that stuff. That's been a huge godsend for me. But it's like there's some weird stuff with XC frameworks that didn't work the way I thought it would, and yeah, but
Yeah, I'm not a huge. I mean, I understand why XC frameworks were created, but I find it really annoying that that's what was done.
it's for a React Native project, so you pick your poison, I guess.
No, no, yes, I know. But what I mean is, XC frameworks are like solving a problem that it's packaging up a whole bunch of different binaries for different architectures in one single thing. But
Right.
like the Mac OS's executable format can do that.
Right.
It
Yeah,
just
I know what you mean.
it just turns out that like XC frameworks can do a little bit more than the Mako format can do, but like
Right.
they could have made the Mako format more capable, and then XC frameworks would be unnecessary.
Right. Yeah.
And I'm just disappointed. Probably that was a very big technical problem to deal with, but I'm disappointed that wasn't done that way.
Yeah. Anything else you want to talk about before we close out?
I don't know. What do you think?
No, I think this has been fantastic.
Okay, great.
There's gonna be a lot of kids in the back of the SUV who are gonna now understand on their Christmas
sure.
road trip
Yeah.
how to do concurrency in Swift 6. So thank you, Matt. Where can people find you online?
You can find me. Well, my website is massicotte.org, and all the links to my my social stuff is there.
Awesome. People can find me on all the social medias at LeoGDion. Mastodon, it's at LeoGDion at c.im. If you're listening to this on your podcast player, please take some time to post a review. And if you're watching this on YouTube, please like and subscribe. Thank you so much, and I look forward to talking to you again. Bye, everybody.